Good morning, students. This is Latif sir. Today I will discuss about determination of molecular formula. In the last video, I have discussed about determination of empirical formula, and I have told that empirical formula is the simplest formula of a molecule. Okay, but empirical formula is not the actual formula of the molecule of the compound. The actual formula of a compound or actual formula of a molecule is the molecular formula. The molecular formula of a compound denotes the actual number of atoms of different elements present in one molecule of the compound. So, molecular formula is the actual formula of the molecule of a compound. For example, molecular formula of copper sulfate, that is blue vitriol, that is CuSO4.5H2. This is the actual formula of blue vitriol. So according to the molecular formula of blue vitriol, it gives the information that a molecule of blue vitriol is made up of one atom of copper, one atom of sulfur, four atoms of oxygen, and 5 molecules of water of crystallization. So the actual molecular formula of blue vitriol is copper sulfate dot 5H2. Similarly, actual formula of glucose is C6H12O6. In the previous video, I have told that molecular empirical formula of glucose is CH2O, while the actual molecular formula of glucose is C6H12O6. Empirical formula is the simplest formula. Okay, it is not the actual formula. So actual formula is molecular formula. And now, how to find out the molecular formula of a compound? There are some steps you have to follow to find out the molecular formula of a compound. First, you have to calculate empirical formula. After calculating the empirical formula, you have to calculate the empirical formula weight of the compound. So the first step is I have to calculate the you have to find out the empirical formula of the compound, and then you have to calculate empirical formula weight from the empirical formula. Okay, in the next step, divide the actual molecular weight of the compound by its empirical formula weight, which gives a number, which gives the common number. Okay, so in the second step, we have to divide the molecular weight of the compound by its empirical weight, which gives a common number. And in the third step, you have to multiply the empirical formula by this number to get the molecular formula. You know the empirical formula of glucose is CH2O. CH2O. But the actual molecular formula of glucose is C6H12O6. Now, if you multiply the empirical formula of glucose, that is, if you multiply CH2O by 6, okay, then you will get the actual molecular formula of glucose, that is C6H12O6. Okay, so to find out the actual molecular formula, you have to, in the last step, you have to multiply the common number. You have to multiply the empirical formula by the common number to get the molecular formula. So molecular formula is equal to empirical formula into the common number into the number. Okay, and how you will get the number? You have to divide the molecular formula. You have to divide the molecular formula by its empirical formula. Okay, so molecular formula is equal to empirical formula into n. So n is equal to molecular formula divided by n is equal to molecular formula weight divided by empirical formula weight. Okay. For example, empirical formula of hydrogen peroxide. Empirical formula of hydrogen peroxide is OH. OH. So empirical formula weight of hydrogen peroxide is 1 plus 16, that is 17. Now the molecular weight of hydrogen peroxide is 34. It is provided to you that molecular formula of hydrogen peroxide is 34, and you have calculated the empirical formula weight of hydrogen peroxide is 17. So what is the value of n? N is equal to, you know that n is equal to molecular weight divided by empirical formula weight. The molecular weight of hydrogen peroxide given here is 34, and empirical formula weight of hydrogen peroxide is 17. So n is equal to 34 divided by 17, that is n is equal to 2. So you have to multiply the empirical formula of hydrogen peroxide, that is OH, by 2, okay, to get the actual molecular formula of hydrogen peroxide. So actual molecular formula of hydrogen peroxide is H2O2. Okay. Now here some examples given. In the exam, in the final board exam, such type of questions will ask to you. Okay, so you have to prepare such type of questions, such type of numerical problems on calculation of empirical formula, molecular formula. Okay, so one more point I have to speak about the value of n. You have to round off the value of n in a whole number always. Okay, sometimes the value of n becomes fraction, so you have to round off the value of n into a whole number. Now see the example 8. So to find out molecular formula, you have to first determine the empirical formula. In the last video I have told how to determine the empirical formula of a compound. So see the example 8. In example 8, it is the question is, a compound is found to possess carbon 40%, hydrogen 6.7%, and oxygen 53.3%. And its molecular mass or molecular weight is given, which is 60. So find the molecular formula of the compound. First you have to find out the empirical formula of the compound, and I have told that you have to make a table, and first in the table you have to make 5 column. One is for element, next column is percentage composition, and next is atomic mass, then atomic ratio, and simplest ratio. So elements present in this compound is carbon, hydrogen, and oxygen, and their percentage are 40%, 6.7%, and 53.3%. And atomic mass of carbon is 12, hydrogen is 1, oxygen is 16. Now we have to find out atomic ratio. Atomic ratio means ratio of percentage composition to atomic mass. So to calculate or to find out atomic ratio, you have to divide the percentage composition of each element present in the molecule is in the compound by their atomic masses. Okay, so atomic ratio of carbon is 40 divided by 12. That is 40 divided by 12 is equal to 3.3. Atomic ratio of hydrogen is 6.7 divided by 1. So atomic ratio of hydrogen becomes 6.7 and atomic ratio of oxygen become 53.3 divided by 16. That is 3.3. And now we have to find out the simplest ratio. So atomic ratio of carbon is 3.3, atomic ratio of hydrogen is 6.7 and atomic ratio of oxygen is 3.3. Now we have to divide all the values of atomic ratio by the smallest value. Okay, so smallest value among 3.3, 6.7 and 3.3 is 3.3. So you have to divide all the values of atomic ratio by 3.3. So the simplest ratio you will get atomic simplest ratio of carbon is 1, simplest ratio of hydrogen is 2 and simplest ratio for oxygen is also 1. So empirical formula of the compound becomes 1 in the empirical formula 1 carbon atom, 2 hydrogen atoms and 1 oxygen atoms. So empirical formula of the compound becomes CH2O. Now you have calculated, you have find out the empirical formula. Now you have to calculate the empirical formula weight. The empirical formula weight of the compound becomes 12 plus 2 plus 16 according to empirical formula. 12 plus 2 plus 16, that is 30, and it is molecular formula of the molecular weight of the compound given 60. So in the question molecular weight or molecular mass given 60 and according to the empirical formula the empirical formula weight become 12 plus 2 plus 16, that is 30. So the value of n is equal to, you know the formula, value of n is equal to molecular mass divided by empirical formula weight or molecular weight divided by empirical formula weight. So in the question molecular weight 60 given and you have calculated the empirical formula weight of the compound is 30. So value of n becomes 60 divided by 30, that is 2. Okay, now we have to multiply the empirical formula by 2. So actual molecular formula of the compound becomes C2H4O2. Okay, so first you have to calculate the empirical formula, then you have to calculate the empirical formula weight, and then you have to find out the value of small n, and in the last step you have to multiply the empirical formula by the value of n. Okay, now see example 9. Calculate the empirical formula and molecular formula of the compound having the following percentage composition. So according to this composition, in a compound carbon is 26.59%, hydrogen is 2.22% and oxygen is 71.19%. And its vapor density given, which is vapor density of the compound is 45. In the last video I have told the ratio of the relation between vapor density and molecular mass, and have told that molecular weight or molecular mass is equal to 2 into vapor density. In the question 9 or example 9, the vapor density given 45, so molecular weight of the compound becomes 2 into vapor density, that means 2 into 45, that is 90. So you have calculated the value of molecular weight, which is 90. Now using the percentage composition you have to find out the empirical formula. You have now again you have to make a box, a table, and in this table you have to draw 5 columns. in one column elements, in another column, in the second column percentage composition, in third column atomic mass, atomic ratio, and simplest ratio. So first write down the name of symbol of elements present in this compound: carbon, hydrogen, and oxygen, their percentage also, that is 26.59%, hydrogen 2.2%, and oxygen 71.19%. And now to get or to obtain the atomic ratio, you have to divide the percentage composition of each element by their atomic mass. So atomic ratio of carbon becomes 26.59 divided by 12 is equal to 2.216. Atomic ratio of hydrogen is 2.22 divided by 1, that is 2.22. Similarly, atomic ratio of oxygen is 71.19 divided by 16, that is 4.45. So the simplest value among this atomic ratio is 2.216. So you have to divide all the atomic ratio of the of all elements present in the compound by the smallest value of atomic ratio. So divide the atomic ratio by 2.216. This is the 2.216, the simplest value, smallest value among all atomic ratios. So simplest ratio of carbon becomes 1 after dividing. Simplest ratio of hydrogen becomes also 1, or nearly. If the value of n, if the value becomes fraction, you have to round off, okay, to the whole number. An atomic ratio or simplest ratio of oxygen becomes 4.45 divided by 2.216. It nearly about 2, okay. So empirical formula of the compound becomes 1 carbon, 1 hydrogen, and 2 oxygen, that is CHO2. CHO2. So empirical formula weight of the compound becomes 12 plus 1, carbon 12 plus hydrogen 1 plus 2 into 16 for oxygen. According to empirical formula, that is CHO2, the empirical formula of the compound becomes 12 plus 1 plus 32, that is 45. Empirical formula weight of the compound is 45, and vapor density given, so molecular weight of the compound is 2 into vapor density 2 into 45, that is 90. So value of n becomes 90 divided by 45, that is molecular mass divided by empirical formula mass or empirical formula weight, that is 90 divided by 45. So value of n becomes n equal to 2. So molecular formula of the compound becomes C2H2O4, okay. Similarly, in the question 10, 0.5 gram of an organic compound contains 0.62 gram of hydrogen and 0.25 gram of oxygen. Percentage of hydrogen and percentage of oxygen given, and it is told that the compound is organic compound. So carbon is also present in the compound, but the percentage of carbon not given. The total mass of the compound given, which is 0.5 gram, 0.5 gram, and percentage of hydrogen and oxygen given. So first you have to calculate the percentage of carbon in the compound. So total mass, you have to find out the mass of carbon first, okay. So mass of carbon is equal to total mass of the organic compound, that is 0.5 gram, minus sum of masses of hydrogen and oxygen. So mass of carbon is equal to 0.5 minus, within first bracket, 0.25 plus 0.062, that is 0.188 gram. So mass of carbon is 0.188 gram, mass of hydrogen is 0.062 gram, and mass of oxygen is 0.25 gram. Now the next process is similar. You have to make a table, and 5 columns are there, at elements, mass of the elements in grams. Here mass of the elements you have to write. Okay, and atomic mass, number of gram atoms. Number of gram atoms means, which is also the atomic ratio. Okay, number of gram atoms means atomic ratio, and then simplest ratio. Simple process like the previous examples. Okay, so you have to write down the symbol of element, their mass in grams. You can see in the box in the table. Then atomic mass of each respective elements present in the compound, and then you have to calculate the number of gram atoms, or the simply the atomic ratio by dividing their mass uh, by their atomic masses. So gram number of gram atoms of carbon is equal to 0.188 divided by 12, that is 0.016. Number of grams atoms of hydrogen is 0.062 divided by 1, that is 0.062, and number of gram atoms of oxygen is 0.52 divided by 16, that is 0.016. Now we have to divide all the values of number of gram atoms by the least value among these three number of gram atoms of carbon, hydrogen and oxygen. The least value is 0.016. Okay, so you have to divide all the number of gram atoms by 0.016. So to get the simplest ratio, so the simplest ratio of carbon becomes 0.016 divided by 0.016, that is 1. Atomic ratio or simplest ratio of hydrogen becomes 0.062 divided by 0.016, that is nearly equal to 4. And simplest ratio of oxygen is 0.016 divided by 0.016, that is 1. Okay, so empirical formula of the compounds become ch-4o, and in this compound it is told that the vapor state, in the vapor state, this compound weighs 32 times as heavy as the same volume of hydrogen, and this 32 is the vapor density of the compound, because vapor density, I have told in the previous video the definition of vapor density. The vapor density is the ratio of weights, ratio of masses of a gas to the mass of same volume of hydrogen gas. Okay, so in this question it is stated that in the vapor state this compound weighs 32 times heavy as 32 times as heavy as the same volume of hydrogen. So vapor density of the compound is 32. Directly it is not said the vapor density of compound is 32. It is given that the weights of the compound in the vapor state is 32 times as heavy as the same volume of hydrogen. So vapor density of the compound is 32. So molecular weight of the compound is 32 into 2, that is 64. Okay, so molecular weight is 64, and empirical formula is ch-4o. So empirical formula weight of the compound is 12 plus 4 into 1 plus 16, that is 12 plus 4 plus 1, that is 16 plus 1, that is 17. Okay, so value of n becomes molecular mass divided by empirical formula mass. The empirical formula weight of the compound empirical formula weight of the compound becomes 12 plus 4 plus 16, that is 32. Okay, 32, the value becomes 32. Sorry, I have told that value empirical formula weight of the compound is 17, not 17, this is 32. Okay, so thus according to the empirical formula of the compound ch-4o, the empirical formula weight becomes 12 plus 4 plus 16, that is 32, and molecular weight of the compound is 64. So value of n is equal to molecular formula by empirical formula. So 64 divided by 32, that is 2. Value of n becomes 2. Hence the molecular formula of the compound is C2H8O2. You have to multiply the empirical formula by this common number, value of n, and you will get the molecular formula of the compound is C2H8O2. Okay, thank you.